Okay. So today we are going to see this instrument called as sonometer. Okay. This instrument is basically used to verify this experiment, that is law of vibrating string. Okay. So we have seen that in this law we have three types of laws. First law is about length. Okay. In length law, what we do, we keep T and M constant and keep changing L. Okay. Let's see with this instrument how we can verify that. Okay. So in this instrument basically we have one wooden box like this. ये जो rectangular shape में एक wooden box है, ठीक है? इसके अंदर इस तरह से holes बने हैं so that it can produce sound. Then we have used one string like this, which is tied to a hook over here, and then it is passed over pulley, and then again added by a hanger where we can add masses. Okay, so at this point we can add weight. This slot is to increase the tension in this string. अगर हमने ये जिसमें अगर हम weight increase करते जाएंगे weight slot में, so what will happen? The tension in this string will continuously increase. Okay. So we have length of this string, we have tension, and if you want to change the mass per unit length, then you have to use different material string. Okay. So first to verify first law of vibrating string. Okay. First law में हमें क्या करना होता है? We have to keep changing this length and we have to keep constant tension and mass per unit length. Okay. तो दो चीजें कांस्टेंट रखनी है. One is tension. So to keep tension constant, ये जो वेट है वेट को फिक्स रखो, वेट चेंज मत करो. जैसे तुमने 100 ग्राम का वेट इसके अंदर पुट किया है तो कीप दैट वेट फॉर होल एक्सपेरिमेंट कांस्टेंट. Okay. Second thing, if you want to keep the constant mass per unit length, तो ये जो हमने स्ट्रिंग लिया है, ये स्ट्रिंग किसी एक ही मटेरियल का फिक्स रखो, उसको चेंज नहीं करना है. हमें क्या चेंज करना है इसके अंदर? सिर्फ लेंथ चेंज करना है. So to change the length, here you have cubical shape A and B. यहाँ पे दो आपको ब्रिजेस दिख रहे होंगे, A और B. ठीक है. जैसे जैसे हम इनको नजदीक या दूर लेके जाएंगे उस हिसाब से उसका लेंथ भी change होगा. Okay. Effective length of this string will keep changing. Okay. So by using this we can verify the first law of vibrating string. Similarly, in the second law, that is law of tension, we have to keep length and mass constant. Okay. So in this, for verifying second law, we have to keep this length between A and B constant. Also, the material of the wire we have to keep constant. That means we are not going to change that wire. Wire वैसे ही रहेगा, same fixed रहेगा. What we have to change is this mass in the hanger. Tension को increase करना है ना, तो tension को increase करने के लिए what we have to change? We have to keep increasing the mass of that slot. पहले 50 ग्राम्स का लेंगे, फिर 100 ग्राम लेंगे, फिर 150 ग्राम लेंगे, फिर 200 ग्राम लेंगे. इस तरह से we have to change the mass and we have to take the reading by using this tuning fork. यहाँ पे tuning fork बना हुआ है, दिख रहा है? कैपिटल T से डिनोट किया. By using this tuning fork, we have to take the readings. Now for verifying third law, that is law of linear density. In that we have to keep tension and length constant. That means इसके अंदर जो weight है mass वो same रखना है. The length of this string would be same, but we have to keep changing this wire. ठीक है. हमें 3-4 वायर की जरूरत पड़ेगी इसके लिए जो अलग-अलग मटेरियल से बने. So that हर एक मटेरियल का जो mass per unit length है वो different है. Okay. Fine. So in this way we can verify these three laws. by using the instrument sonometer. We are going to do the experiment on sonometer in our lab. So in detail, I will tell you there in the experiment. Now, moving on to the next topic, that is beats. Okay. अभी तक हमने पढ़ा स्टेशनरी वेव, करेक्ट? Then we saw how we can obtain a stationary wave by using string and by using pipe, which is closed end, open end, or closed at both ends. Now, let's see what is mean by wave. Okay. So suppose we have two waves. We have two waves of same amplitude. हमारे पास दो वेव हैं जिनका एम्पलीट्यूड सेम है, but they have slightly different frequencies. Okay, they have the frequencies of these two waves are different, and most important thing, they are traveling in the same direction. ये दोनों एक ही डायरेक्शन में ट्रेवल कर रहा है. स्टेशनरी वेव में वी हैव सीन दैट कि जो वेव होता है वो अपोजिट डायरेक्शन में ट्रेवल करता है, but here for beats, for producing beats, the waves are traveling in the same direction. Okay, here you can see an example. Here, yeah, this one. So this is the first wave which is moving in this direction. This is the second wave which is moving in this direction. Both have same amplitude. Okay, but they have slightly different frequencies. Okay, so when they are moving from same path, they get added up. ठीक है, तो वो दोनों एक दूसरे को ऐड होके इस तरह का स्ट्रक्चर बनाते हैं, where we at some places we have maximum amplitude and at some places we have minimum amplitude. Okay, the places with maximum amplitude are called waxing. ये जो maximum amplitude वाला part है, this part is called waxing, and this part, this point which have minimum amplitude is called vanning. Okay, so here you can see they have said the occurrence of maximum intensity or maximum amplitude is called waxing, and those for minimum intensity or minimum amplitude is called vanning. Now I will use board to write this one, that is an analytical method to determine beat frequency. Okay, so we are going to use some mathematical expressions to define beats. Okay, so let me start sharing that. Just wait. So our topic is beats. Okay. In beats, what happens when two waves of same amplitude but different frequencies are traveling in same direction, they form a structure like this. Okay, so these things are called waxing, and these points are called vanning. Okay, waxing means they have maximum amplitude, and vanning means they have minimum amplitude. So to define this, we are going to use mathematical expression to write the equation of frequency of beats. Okay. So topic is analytical method
नहीं दिख रही
analytical method to define to determine beat frequency. Beat frequency. Okay. So we have to consider two waves. Okay. Both are moving in same direction and they have same amplitude but different frequencies. Okay. So let me write it. Consider two waves of same amplitude but different frequencies. Moving on same path. In same direction. Okay. Then the expression for them can be written as
बोर्ड क्लियर नहीं दिख रहा
बोर्ड क्लियर नहीं दिख रहा है
क्लियर सर
सर क्लियर है
हाँ बोर्ड पे थोड़ा ब्लर हो जाता है क्योंकि कैमरा हम लोग कॉलेज का यूज कर रहे हैं ना तो थोड़ा बहुत समझ के लेने का ओके नाउ वी हैव टू राइट द एक्सप्रेशन फॉर दोस ओके सो फर्स्ट वे वुड बी y1a sin 2 pi bracket close n1 t minus x divided by lambda. So this is the equation for first way. Okay, here we have taken a different frequency. The name of that frequency is n1. Okay, this expression we have already written in the previous section when we were studying about stationary wave. So you are aware of this expression. Now for second wave I will use the symbol y2. We have to take same amplitude, so here also a sin again 2 pi. Both waves are moving in the same direction, therefore we will use negative sign for both. Here I have to put n2 because for both we have to take different frequencies, then x divided by lambda. So this is equation number 2. Now next, let us assume that to simplify this equation, ये equation को थोड़ा simplify करने के लिए ये हम लोग जो displacement है, that is x, इसकी value कितना put कर देते हैं 0. So लिख देते हैं for simplification put x equal to 0. Okay, so when I put x equal to 0, I will get the equation as y1 equal to a sin 2 pi n1 t. Similarly, y2 equal to a sin 2 pi n2 into t. Okay. Now what happens next? We know that both waves get superimposed on each other. That means we have to add these two equations. Okay, so by principle of superposition, the resultant wave is y equal to y1 plus y2. Okay, y equal to y1 plus y2. Now we have to add these two equations, so let's substitute. So it will come out to be a sin 2 pi n1t plus a sin 2 pi n2t. Okay, next we have to for simplifying this equation we have to use one formula, and the formula is sin c plus d. Who remembers this formula, sin c plus d? It is written as 2 sin c plus d divided by 2 into cos c minus d divided by 2. Okay, so we are going to use this formula to simplify this. This whole thing is c and this one is d. So we can write, let me remove this, you know it. So we can write y equal to 2, a तो दोनों में कॉमन है, so 2a, then sin. Again, if you see 2 pi is common in both, so I can take common 2 pi. Also t is common, so I can take t common. In between we have to add n1 plus n2, n1 plus n2. थोड़ा बड़ा लिखता हूँ, n1 plus n2 into t and divide by 2. Similarly, multiplied by cos, again 2 pi, then n1 minus n2 divided by 2 and into t. Okay, जो बोल रहा हूँ ध्यान से सुनना, ये थोड़ा सा है ना. Okay, n1 minus n2. Here we have n1 plus n2 and cos n1 minus n2 multiplied by this t. Okay, is it understood?
Yes, sir.
Now after that rearrange this equation. Rearrange this equation. How? Just take this cos over here. मतलब cos को थोड़ा आगे लाके यहाँ पे लिख दो, sin को पीछे लिख दो. So this equation will become y equal to 2a into this cos term. Take it first. That is 2 pi n1 minus n2 divided by 2. I have to use this bracket here. Multiplied by this sign. Sign का क्या है? 2 pi n1 plus n2 divided by 2 into q and this bracket. Okay. So we have rearranged this equation. Now let me rub this. This is available in your textbook, so no need to. Now, next step is put this whole thing in the amplitude form. इसमें देखोगे तो सारी चीजें constant है, तो basically I can keep this whole thing as amplitude. So we can select let 2a into cos 2 pi n1 minus n2 divided by 2 into t इज इक्वल टू कैपिटल ए। ओके, तो ये पूरे टर्म को मैंने क्या सिलेक्ट कर दिया। ऑल्सो ये जो n1 प्लस n2 डिवाइड बाय 2 है, सेलेक्ट दिस एज n। ऑल्सो n1 plus n2 divided by 2, keep this as capital N, capital small n, let me check, small n. Okay, so if I substitute this value in this equation, I will get y equal to 2a। ये पूरे टर्म को क्या सब्स्टिट्यूट कर दिया, a, then sin 2 pi, this whole term is substituted as small n into t। Okay, so if you see this equation, this is equation of an stationary wave। Okay, so this is equation of stationary wave। That means ये जो हमारा कौन सा वेव है, बीट्स है, ठीक है। These beats are also one form of stationary wave। Okay, is it clear? यहाँ तक समझो?
Yes, sir.
Yes, sir.
Okay, now next, so we have found the expression for the R beats. Now we will use this equation, that is expression for amplitude, to find the condition for waxing and waning। ठीक है, तो पहले पूरा रफ कर देता हूँ, सिर्फ एक इक्वेशन रखूंगा। सी हमारा जो डायग्राम है वो कुछ इस तरह से है। These points are called waxing or waning। Yes, this is called waxing, which means amplitude is maximum। Okay, amplitude is maximum, and these points are called waning, which means amplitude is minimum। And here we have the expression for the amplitude। Okay, so by using these two conditions, we are going to find the frequency or expression for amplitude। Okay, expression for waxing and waning। Okay, so first of all, let's take the case number 1। When when amplitude is maximum, bracket में लिखना waxing। When amplitude is maximum, that means the value of A is either plus or minus 8। See here, in this wave we have two type of wave। For first wave the amplitude was A, for second wave the amplitude was A, so the total amplitude of this would be plus or minus। Now if I substitute plus or minus 2, A plus A 2A. Now if I substitute this value over here, then I will get, therefore,
Yes.
2A cos 2 pi n minus 1 n1 minus n2 divided by 2 into t equal to plus or minus 2a. So this 2a, this 2a gets cancelled. Okay, that means we have found that whatever inside is, the value of cos is plus or minus 1. This implies the value of cos 2 pi n1 minus n2 divided by 2 into 2 is plus or minus 1. Okay. Now tell me at which point or at which angle the value of cos is 1. Anyone? At which degree the value of cos is 1? Cos की value 1 कब होती है? कौन से एंगल पे?
60.
First is 0, cos 0 is 1, correct? Cos 0 की value 1 होती है. Then after that, correct, cos 0. Then next is cos 180, that is pi. From here we can conclude that this value is equal to, therefore यहाँ से लिखता हूँ 2 by n1 minus n2 divided by 2 into t is either equal to 0, या तो 0 के equal है, or it is equal to pi, or it is equal to 2 pi, or and so on. ठीक है, तो इसकी वैल्यू 0 पे 0 1 होती है, then at pi it is 1, then at 2 pi, then 3 pi, then 4 pi, then 5 pi and so on. Okay, now if you compare with this पहले वैल्यू से अगर कंपेयर करें इस इक्वेशन को, ठीक है, तो यहाँ से हमें क्या फॉर्म होगा, क्या मिलेगा वो देखना है. So if I compare this with 0, I will get ये पूरा टर्म इधर आएगा 0, then this term will come over here 0. So we will have n1 minus n2 into t equal to 0. That means the value of t will be equal to 0. Okay, तो अगर 0 से कंपेयर करेंगे तो इसकी वैल्यू कितनी आ रही है, t 0. For next term, if I compare with pi, okay, अगर pi से कंपेयर करेंगे, this pi gets cancelled, this 2 gets cancelled. Okay, so you will get t equal to 1 upon n1 minus n2. ठीक है, और सेकंड टर्म अगर पाई से कंपेयर करोगे तो t की वैल्यू आएगी 1 upon n1 minus n. अगर 2 पाई से कंपेयर करोगे, so this 2 pi gets cancelled. Okay, so the value of t would be equal to 2 divided by n1 minus n2. Okay, तो पहला 0 आ रहा है, नेक्स्ट n1 minus n2 आ रहा है, next then 2 divided by n1 minus n2 आ रहा है. So we can write in general therefore जो t की वैल्यू से वो कहां गया है, पहली t की वैल्यू 0, then next value is 1 upon n minus 1 n1 minus n2, then 1 upon 2 upon n2 minus n1 minus n2, then next 3 upon n1 minus n2 and so on. Okay, so at this time period we get maximum, maximum amplitude, which means we get waxing condition. Okay, तो जब टाइम पीरियड हमारा 0 रहेगा 1/n-1 n2 रहेगा और 2 divided by n1 n2 रहेगा. At these conditions we get vaccine. ओके, तो इस टाइम पीरियड के बाद हमें क्या मिलता है? वैक्सीन मिलता है. नाउ इफ यू सब्ट्रैक्ट, अगर इसमें से इसको सब्ट्रैक्ट करोगे तो टोटल टाइम इन दोनों के बीच में टाइम इंटरवल कितना आएगा? 2 में से 1 माइनस होगा तो 1 बचेगा. दैट मींस टाइम इंटरवल between two vaccine
माइक म्यूट करो.
is 1/n-1. ठीक है, इसमें से भी किसको माइनस करोगे तो हमेशा यही कंडीशन आएगा कि दो वैक्सीन के बीच में जो टाइम इंटरवल है वो कितना है? 1/n-n1. सी है, इसमें से भी इसको माइनस करोगे तो 3 माइनस 2 कितना बचेगा? 1. दैट मींस 1/n-1. ओके, n1 minus
Yes, sir.
n2. Similarly, now we will find for vanning. जैसे अभी वैक्सीन का कंडीशन फाइंड आउट किया, तो अभी वैनिंग में देखेंगे कि क्या होता है. कितना टाइम बचा है?
माइक ऑन है सुभाषी.
ओके, देयर 5 मिनट तो हो जाएगा. अगेन लेट मी राइट द इक्वेशन फॉर एम्पलीट्यूड. इक्वेशन था 2a cos 2 pi n1 minus n2 divided by 2 into t equal to a. Okay. In the vanning condition, for vanning, the amplitude is 0. Amplitude कैसा है? Minimum. Okay. So if I substitute this value over here, then I will get, therefore 2a cos curly bracket 2 by n1 minus n2 divided by 2 into t curly bracket close equal to 0. a की वैल्यू 0 सब्स्टिट्यूट. सो यहाँ से अगर सिंपलीफाई करें तो हमें पता होना चाहिए cos की वैल्यू 0 कब होती है? At which point the value of cos is 0. कि 2 pi उधर जाके मल्टीप्लाई होके 0 हो जाएगा. So I can write this as cos 2 pi n1 minus n2 divided by 2 into 3. So at which angle the value of cos is 0? The answer is at 2 pi n1 minus n2 divided by 2 into t. कब होता है? फर्स्ट एंगल इज pi by 2. करेक्ट? cos 90 0 है ना? Then next is 3 pi by 2, then 5 pi by 2, and so on. So if you compare, start comparing with this one, you go. If you start comparing these two, इसको इससे कंपेयर करेंगे, इसको इससे कंपेयर करेंगे, then you will find that therefore कि जो वैल्यूज आ रही हैं t की, वो सबसे पहले आएंगी t इक्वल टू 1/2 n1 minus n2. पहला ये आएगा. ठीक है, फर्स्ट अगर इससे कंपेयर करोगे तो then after that you will get 3 by 2 n1 minus n2. Then again after that you will get 5 divided by 2 n1 minus into and so on. ठीक है, तो वापस वही हमें मिलने वाला है 1 के बाद 3, 3 के बाद 5, 5 के बाद 7 and so on. So these are the time intervals at which we get the condition of varying. Okay, अगर किसी एक में से एक को माइनस करेंगे, जैसे इसमें से इसको माइनस करो, so 3 minus 1 will give you 2. Okay, this 2 and upper 2 will get cancelled, so time interval again you will get time interval between varying is अगेन वापस अपने को वही क्वेश्चन मिलने वाला है, कौन सा 1 अपॉन n1 माइनस n2. ठीक है, तो दोनों के लिए जो टाइम इंटरवल है वो सेम, दैट इज 1 अपॉन n1 माइनस n2. ओके, अंडरस्टूड और नॉट?
Yes, sir.